Good afternoon, everybody, and welcome to JP Morgan Chase Rutgers Alumni Group's presentation of our latest Lunch and Learn program. I'm excited to introduce an outstanding panel today talking about data science and how data science from various academic units within the university is utilized across business units within organizations. And I'm proud to introduce the panelists here. I'll start off with our moderator, Ronak Parikh, who is a professor within the Rutgers Business School and also works for Amazon. So brings a very unique perspective from industry and academia as well. We have Professor and Chair of Industrial and Systems Engineering from the School of Engineering, Mohsen Jafari. Welcome, Mohsen. From the School of Management and Labor Relations, Professor Michael Sturman. Thank you, Michael, for joining us. And from the School of Arts and Sciences in the Department of Economics, Professor Norman Swanson, who will be sharing his expertise as well. So for the next 40 minutes or so, we will engage in a healthy dialogue amongst the panelists. I recommend that anybody who has any questions, and we encourage as many questions as you possibly can, to type those in the chat box. We will address those towards the end of the program. And one last thing before we actually get started, I'd like to thank the JP Morgan Chase Rutgers Alumni Group and the leadership board over there, who have done an extremely wonderful job in getting the over 900 alumni who work at JP Morgan Chase aware of what the program is about and how to get re-engaged within the university again. So at this point, I will turn this over to Ronak and come back to you later. Thank you.
Yeah, no, thank you, John. Thanks for assembling this panel with deep expertise in each functional area of data science. In some sense, I feel we would make a perfect team, a data science team, with an economist, a technologist, a HR specialist, a product manager. So, I want to start this discussion with very simple definition. And what I noticed early in my career, when data science was not a term frequently used, and as the term became more mainstream, it took on various meaning. Even now in conversations, I find that the data science term differs from individual to individual. So to start this discussion, fellow panelists, how would you define data science and what expectations do you have when an organization uses data science? So Mohsen, why don't you go take this one first?
Thank you, Ronak. It's very nice to be here. So I'm going to give you more of an engineering perspective to data science. First of all, as you said, there are many parallels between data science and what we used to have in statistics. In the past, we had all these statistical models, but what we didn't have much was data and also computational resources. With the data science, and I would say in the last 10, 15 years, we have abundance of data. We also have lots of computational power. So it really makes lots of analysis and computation possible. And that's what we have seen in the last, I would say, 15 years or so has been happening with the data science. But if you look at it from this engineering perspective, we are doing data science mainly for two reasons. Either we are doing analysis, where we want to explore and identify patterns. We want to classify data, input data. We want to estimate some sort of behaviors and so on, or do prediction. Or we are doing synthesis, meaning that from past data or on the basis of learned knowledge, we want to generate new patterns, new models, new rules, make induction on some new hypothesis and some new rules. So this is basically what we do in data science from the engineering perspective. But again, there are many parallels between data science and statistics. There are many models that if you look at it, the roots are in statistics. But it's good to have all this computational power, also abundance of data to be able to apply these.
Yeah, no, I can see the statistics and computer science coming together. And with that, Norman, what would you add to this?
I think that I agree with Moshe completely that there are various different interpretations of what data science is. And I think, in a nutshell, I would just say it's the formal analysis of data. And I have to say that when I began in academics at Penn State 2 or 3 decades ago, there was the one most common request that I received from business was, please train your students in the analysis of data. We need people that can crunch data. And it was, I had just finished my PhD at that time, and it became abundantly clear to me that there was a huge demand. There's always been a demand for data science. This is just a new term, just like big data is a new term that has lots of different meanings. And in some sense, I guess I would view it as an evolution of what we've always done. I would argue that in business, for example, we've always used information. Anybody making any decision in any aspect of life, but in business is the case we're talking about, uses information. Even if people have sort of a gut instinct, that gut instinct is based on information that they've gathered over time. They might have a great processor or a great model in their brain implicitly working, but they're still using information. And what's happened in the last couple of decades is we have benefited from the accumulation of an enormous new amount of data, and along with that has come the opportunity to, rather than simply using information, which wasn't in the form of data yet, we're now able to actually use the data formally.
Yeah.
And so data science, in some sense, in my view, is simply a way of formalizing the notion that we have a lot of data available and we can use it formally using, science in general has always progressed in a couple of directions. One direction is theory first, and then data. And the other direction is data first and then theory.
Yes.
But data has always been involved. And people like me that focus primarily on the development of statistical methodology used in forecasting are sort of firm believers in the data first and then theory. But I can tell you there are a lot of economists, not like me, not econometricians, that believe in theory first and then data. But at the end of the day, the bottom line, in my view, is that we're simply talking about the formal use of mathematical and statistical and engineering and all other methods available for the analysis of the data that we now have available. That would be my definition.
Yeah, very well said. I mean, so I went for my bachelor's in computer science at Rutgers, and in my computer science curriculum, the focus on data was very minimum. And after graduation, I took a job at Bloomberg where I realized data took a front seat. Like all the decision making was done in investing via data. Sometimes data was used to automate processes, and I almost had to learn everything on the job there, right? And that made me say, hey, I want to get deeper into the statistical side. And so I went on to get my MBA. But I agree with you. I think the data science term, there was a definition given, but the processes were always there. And it's just that it's become, with more and more data is taking center place now.
Yeah. When I was a young person, like many of the viewers here, and when I was an undergraduate student, I loved data. And the state of data at that point was I drove to Toronto, 3 hours away, went to a library in a dark place and collected some old books that had some numbers in them, transcribed those numbers onto pieces of paper and put those numbers created a data set with, a couple dozen observations and did some sort of an analysis with it. And, I guess, like you say, Ronak, we've come a long way.
Great.
Data is everywhere now.
Michael, love to hear your perspective on data science.
I don't have too much to add to what's been said, except I would actually make it a simpler definition of just it's using data to support decision making.
Yeah.
And it doesn't have to be AI algorithms. It could be a mean, a mode. What's the average? What does the distribution look like? To very sophisticated analysis. But it's this idea of moving, as Norman said, from intuition to data-supported decision-making, evidence-based decision-making. And the trend with the data science is using data and the availability of data and novel ways of making data available to help make that happen and help support that kind of decision-making.
No, exactly right. So a lot of companies want to do inferencing with data science. However, to do inferencing, you have to understand data, and that requires some very basic what-if analysis, getting to know the data better. I often read McKinsey Quarterly, and they raise the bar on thought leadership on data science and data analysis. And recently they mentioned that customer analytics, where companies heavily invest to get to know their customers better, they are more likely to outperform their competitors by 23x to acquire customers, and 6x to retain them, and 19x to be more profitable as a result of acquiring and retention. And I was trying to see if I can find examples of data science in the non-customer facing use cases, and the findings were sparse. So I would love to hear, are there examples where data science is used in departments that are not customer facing or in back office? And I think, Michael, why don't you take this one first?
So absolutely, I would say that. My whole existence is based on that there. As a human resource analytics person, you could argue employees are internal customers, but most people would not call human resources a customer-facing department. But what I study is looking at how you can use analytics to make better hiring decisions, help predict who's going to leave, make better prevention of turnover or encourage turnover where you want it, how to pay for performance more effectively, how to ensure that the money you're investing in people goes a much longer way. It's sort of an irony of my life. I have a PhD in human resources. My brother actually has a PhD in computer science, and he's an executive in an organization. He spends a lot more time doing human resources than I do. I spend a lot more time programming than he does programming, and he spends so much of his time dealing with human resource issues, and he's constantly looking for data to support those decision making. He has an individual who works for him that does the personnel analytics, as they call it, the human resource analytics, and they're looking for how can we make better decisions to support this key task of managing the people within our organizations. So I would definitely say that human resources is a key area that benefits from analytics that isn't facing the customers directly.
No, the great example. And I often find customers have a hard time finding the right people with the right skill sets to help them become more data driven. And I'm so thankful for universities like Rutgers that have an executive education program just to make first-time managers prepared to bring this to their organization. Norman, do you have any examples that go on the non-customer facing side?
As Michael said, human resources is a great example. I think I would also agree with, am I off of mute? Yeah, I think I would also agree with Michael wholeheartedly. My interpretation of what he said is that the data science is involved in every back office, in every aspect of every business. To me, the only question would be, to what extent is data science involved? To what degree have they evolved their use of data? So for example, if you think of an insurance company, I did a lot of consulting over the years with insurance companies. A couple of the primary things they do, which are back office things, are pricing policies and allocating assets. When people pay for policies in the insurance industry, the companies take the money and they invest it. They invest it because they want to collect returns and build their cash reserve as much as possible, because they're going to be using that cash reserve to pay out policies and claims. And so when they do pricing, they're forecasting the number of claims that are going to occur and the magnitude of the claims. And all of that is back room. And when it comes to things like asset allocation, which are our back room, asset allocation occurs in not just in insurance, but in banking and investment banking. And you know, I would argue that every firm should be concerned with asset allocation. If they have money on the books, they have to take care of it. And so anybody that collects revenue is going to hire or use to some degree a person that's adept to some degree in data science, in the sense that they use data to optimize their investment portfolios, for example. So, but I think it permeates across all departments. And as Michael alluded to, it, you know, depends. Some use it more, some use it less. But I would argue that everybody is using it more, and the trajectory is more. And I think that that's probably not a very contentious statement.
Agreed. Motion, what's your take on some of the back office use cases?
Excuse me. So, I mean, if you look at many engineering systems or business applications, like there are many applications in predictive analytics, in maintenance, asset management. There's so many, there is a huge array of application areas that in decision making and control, you can use data science. And it's being used. Now, is it fully being used, and is it rightly being used? I think there are some debates over there. And this may come up actually in your following questions, but it also a bit relates to your previous question in terms of, to me, there is a big difference between learning from data and understanding from data. And what is going on right now is there is a lot of learning from data, and we have very sophisticated models, and there are many people in the back end or front end that try to do that. But I'm not sure if we are good as academia or as industry in terms of understanding from data. And this deep understanding is something that I'm hoping is going to come to surface in the future from the data. Again, think about it, data is the past. Data is what you have observed. Data doesn't tell you much about the future, especially if you don't understand the physics of the future. So I think there are some challenges there, but overall, in terms of where it is used, there are many applications that's being used in predictive analytics, predictive control, asset management, maintenance, you name it.
Yeah. No, I remember like using data science or data analytics to lower cost, right? And I remember like a case study that's widely used at least 20 years ago when I was doing my MBA was the Dell use case on just-in-time delivery, right? How do you order just when the customer needs it, so then you're not incurring cost in storage? And so I'm so happy to hear all these examples, and it's immensely clear that data is an important asset to an organization, and significant numbers of companies are on the path of becoming data excellent, I guess, but at a different pace, right? Now, however, when I work with executives from my program, I often find a blind spot in terms of data collection, and I'll explain. So what happened was a recent survey from Seagate, which is a data storage company, quantified my suspicion that the blind spot is quite common. And what they found was organizations collect only 56% of the data that's potentially available through their operations. And out of this 56% that they do collect, only 57% of the data gets used, which means 43% is largely unleveraged. And another survey from Splunk found that 60% of the organizations say more than half of their organization's data is not captured, and more of it is not even understood to exist. So it's always good to see two independent surveys validating my suspicion, right? And as a side note, as a data science practitioner, it's always good to trust but verify. So the question becomes, what do you attribute this large gap of not using the data you're collecting and not collecting the data you might need to? Motion, you go first. I'll start with you.
Sure, I'll be happy to. Again, I am quoting some of the some statements from a recent McKinsey report that there is a gap, and they called it data translators. I don't know if that's the right term or not, but that's really a term that bridging between the back end on the data side and the front end business functions. And apparently that is big time missing. And we also see that that is missing. So it's really understanding the gaps in terms of business or your engineering or whatever applications that you're dealing with and relating it to data. Now you have people on the back end who are very good in the data science, on the mathematics, algorithmic, developing algorithms, writing programs. You have in the front end, you have all these business people who are doing great jobs, but linking the two and bridging the two is apparently what is big time missing. People that can understand the two and relate the gaps in both ends. And this reminds me of many years of IT functions. IT always had problems in the industry because it was not clear where they stand and how it relates. Now I presume that it has gone away. I have some years of experience in industry, but I haven't been there for some years now, so I'm not clear on that. But to me, that is something that is missing in terms of really understanding the need for it, where to do it, where to use it, and also people who can translate the data, the findings from the data to what the business functions need. I mean, at the end of the day, some of these models are very complex, and require lots of training, lots of you name it. But to bring it to reality and bring it to business needs is something that I see companies are struggling with.
Yeah. In some sense, I think it's like asking yourself, not that we have the data, but do we have the right data with us, right? And I remember the first project when I started working, we had to decide how much data retention to do, right? Like actively think about, do we need 1 month of data? And I'm so happy that these questions have gone away, right? The cost of storage has gone down so much that no one needs to think about pruning data.
If I may just add one more point,
yeah.
And we can discuss it later. I think this issue of the human machine system or human AI, human machine learning, whatever that you call it, I think the nexus between the two and how these two should be really working is something that is going to define the future in terms of workplace. And right now, I think there are many gaps on it. It's not very clear how human decision-making and machine-based decision-making should really complement each other. I think we are missing that. And again, it goes back to my point earlier on deep understanding of the problem rather than just learning. So I think these are some contributing factors.
Yeah. Norman, what would you add to this?
I think I would add that the one thing that seems to have remained constant over the last few decades is that the capability of our computers has always been less than what we want to get out of them. In other words, even though we have incredible computers that are incredibly fast, the theory that we've developed and the methods that we've developed could certainly take advantage of much faster computers. So there's always been a question of allocation of computational resources to our data, and that is, you know, even in the very simplest econometric context that I would think about, even if you just have 100 variables. And all you want to do is fit a simple linear model of those 100 variables, and you want to optimally select from those 100 variables. There are 2 to the n, where n is 100 different permutations. You cannot run all the permutations, even with our fastest computers. So the notion of this 56 and 57% that you were mentioning, Ronak, really boils down, in my view, to collecting data is costly, and we need to decide what data to use. That's it. And we have teams of people that are collecting the data. Hopefully they're interacting and collaborating with the teams of modelers that are doing the forecasting or constructing the models. But the communication the channels of communications are not going to be perfect. And we have a virtually infinite amount of data that we could collect. So the notion that we're collecting 56% of the data, to me, that seems a little bit of a leap in terms of the assumptions that must have been made in order to come up with that number. I could think of an infinite amount of data that we could collect. I think what they might mean is that we're collecting 56% of the data that we currently have available to us to collect.
True.
We can think of an infinite amount of data that we're not collecting, and we haven't even defined it yet. We haven't even named the variables. So 56% to me seems a lot.
Yeah.
And the fact that they only use 57% of it, I think that might have, that's very interesting. And it would be nice if we had some more efficiency. I think, as Ronak suggests, there's a great degree of inefficiency in this here. And since we're using so little of the data, maybe we could build better communication channelers between the data management specialists, because it's a discipline in its own right now, and the practitioners who are carrying out analytical analyses and developing statistical tools. Sometimes it's difficult to talk to scientists because they're not very good at communicating. So those data guys but the data guys are computer scientists. They might also have a hard time communicating. So that's my view.
And I agree with you. It's hard to not use something when it's so accessible, right? It's like, oh, I have 100 variables. Let's put everything in the regression model and then start down. Where before you had to, because data collection was so expensive, you started with one model, you added another variable, and you were like, okay, this is good without overfitting.
Right. You know that in economics, the term data mining used to be a bad word up until the 90s. And the reason it was a bad word is because of overfitting. Because you could imagine throwing everything, including the kitchen sink, in there, and somehow you'd get a better fit, but you wouldn't get a better prediction. And so it's not a bad word anymore, because the new methods that have been developed for big data analysis are cognizant of overfitting, of the problems of using too many variables. So they try, half of the discipline is concerned with how we pare down the number of variables.
That's right. You should always ask, do I need to use this before it enters into anything? Exactly. Agreed. Michael, would love to hear your thought on this.
So I think, as Norman alluded to, I think a lot of this comes down to skills gaps. That there, what to do and how to do it is, I think, preventing a lot of the potential that's there. And a lot of that also relates to time. I mean, you have to remember, all these decisions are already being made now. Maybe not with data, but still decisions have to be made. Things have to be ordered, people have to be hired, inventory has to be purchased. And one of the real challenges is to say, well, let's start doing with data. You still have to keep making your decisions. You still only have that work week in front of you. And now you have to somehow carve out the time to say, let's start building this model. Now, some companies will have the analytics people to help support that decision-making. And sometimes those models are helpful, but sometimes they're not. But it's a risk that has to be willing to be took. And a lot of times there's just only so many hours in the day. You have to get those decisions made. And changing how you make decisions is a real great challenge for organizations. When you put on top of that it's a highly complex change to something you're already doing in whatever context you're in. So you need to be able to look forward to, where's the potential? How can we make better decisions? What will better decisions really look like? And where's that benefit side to that? To embrace the idea of saying, this number of hours of the week where you were doing this work that still has to get done, we're going to cut that out, put it somewhere else, and now you can work on this other project to try to support the decision making and hope it works out.
Yeah. Now, going back to the point that Motion said, I think companies need to start with, what's the problem that we have, and work backwards from there to say, for this problem, do we have the data? If not, start collecting it, etc. Rather than going from data to say, hey, data, tell me what problems you can help me solve, right? And those might not be strategic enough. So I love this discussion. Now, as someone who works in data every day, dealing with ambiguity is expected, right? You're presented with different information that often conflict with each other. And earlier this year, I was reading a survey from New Vantage Partners. And what they do is they do a survey with executives in Fortune 1000 companies. And they interview mostly 77% of these survey responders are chief data officers, chief analytical officers. And what they found was actually very counterintuitive, that organizations still face a potentially long road ahead of them in terms of the effort to become data-driven. And in 2022, so this was January 2022, they found that less than half the respondents replied that they were really competing on data and analytics. And only about 40% of said they were good at managing data at an enterprise level, as an asset. And barely over 25% reported that they have created a culture of data-driven organization. So, but we also know that people who do become data-driven organization, they get more revenue, they're more profitable than their peers. So clearly there is a financial benefit of being data-driven, but the unexpected ambiguity is that why are some companies or departments not taking the leap when the reward is clearly there, right? So Norman, I would love to hear your thought on this one first.
It's interesting that you say that my son a couple of years ago was working for Comcast, and he told me he was doing data analytics there, and he told me that that he was trying to do a little bit of forecasting for them, and they were trying to incorporate data, the new plethora of data that's available in some of their decision making. And the way they did it there was they had an external data warehousing firm in a different country that housed the data. And then they had some people that processed the data in yet another different firm. And then they would ask for the data, and then they would eventually get some data. Oftentimes the data that he was able to get was not in the form he wanted. And it was, and he wasn't even clear on whether the data was accurate, some of it. And then he would process the data using his analytical tools that he had. And so a lot of the firms, I guess, they have to decide how they want to spend their resources. If they think it's going to be cheaper to outsource to the cloud or to various different services, various different parts of the data science world that they're trying to get involved with, then they're naturally going to have impediments to sort of productive use of their data. But at the same time, if they want to do sort of in-house data management and hire enough experts to analyze the data, it becomes costly and it becomes difficult. Just like in engineering, in data science, there's always a need for more people. There's always a shortage of people that are willing to do the more complicated things. And so that's why that great demand that I mentioned for data science in the 90s wasn't called data science then, but that's what it was. Yeah. That great demand is here even more so than ever. There's just not enough people to do it. So perhaps part of the reason this happens is because they're kind of forced to do it. It's just too costly to try and set up the internal units. And because of that, it becomes inefficient. And yep. they don't, and the decisions and their decision making doesn't benefit as much as it potentially could. So they don't see the returns.
Yeah. I agree with you, Norman. It's like you will be forced to go down this road. It's saying, are you going to force yourself, or will let external forces let you take this journey? So right. Yeah. Michael, what's your take on another? Exactly.
So, I mean, I firmly believe that data analytics are the future and are going to be necessary to be more effective. That said, surveys like you mentioned, I think actually create some trouble. I think the companies that invest more in data analytics are the ones that are currently profitable with growing profits. And then they have slack resources, they invest in data analytics, and then surveys look, the companies that invest in data analytics are more profitable. But meanwhile, those companies are going, we're not seeing the return from this specific project and are getting discouraged. Yeah. So I in general find with companies that I talk to about data analytics that there's a general fear of missing out, this FOMO. Every company I talk to, almost not all, but most companies I talk to about this think another company is doing more than they are. That they're doing something with AI. They don't know what that means, but there's something AI going on that they're doing that they're not doing, or that they're getting more data or using it more effectively. And I think this causes troubles in this investment because companies start going either, well, we can't invest that much it's too big of a project, so they don't go down that road yet, or they're not seeing the returns that they think they should be seeing because it's a much more gradual process.
Yeah. Motion, what would you add to this?
Well, actually, there's not much to add. I mean, Michael and Norman just said everything that I would say, honestly. So I'll pass on.
Yeah, when I teach my class in statistics, I tell people, like, I give them like data that's all tidied up, right? And I tell them, look, in real life, this is not the case. You won't get a file handed to you that's perfect, right? I spend like more than half my time like making sense of the data, understanding the context in which it was collected. Is it going to answer the questions I need to? So I think there's some of that as well. We underestimate how much effort still cannot be automated, or we underestimate the time it will require for us to do it correctly. So, and to this point, it's like, I know this data, again, I'll stick to surveys just because, I want to make this more data driven as well, this talk. And the survey is 2 years old, but still, I think very insightful. And it was done by Boston Consulting Group. And what they found was, if we reduce the universe to companies where the leadership is leaning in, to go down this, create this data-driven culture, they still find that 70% of the digital transformation projects fall short of their goal. And I think it was you, Michael, who suggested that, they're not getting the return. So can you expand on what you were saying before, a little like more on that topic? Why are companies not seeing the return on their investment, even when leadership is heavily leaned in?
Well, I think it's two things. One is expectations are often too high because of all the hype around data analytics. And two, it's hard. I mean, it's a learning process. It's it's the economics theory that if it was so easy, someone would have done it already, so to speak. It can't be $100 on the ground because someone would have picked it up already. And so these are difficult things to figure out how to do. Novel decisions, novel decision-making practices, changing the way business is done is never easy for organizations. That kind of work. And the company supports it, but sometimes they say they support it, but by the way, we still need to see these numbers come back right. We need to see, you got to get these other parts of the job done. So it's a real commitment to make this analytics go successfully. And you have to have, I think, more realistic expectations of the time it's going to take and what you're going to see coming out of it. Yeah.
Motion, what's your take? Find something similar?
To me, data science is, at the end of the day, it's a technology resource, something that, you want to adopt, and adopt in the best possible way. Now, how you adopt it and what way you do it, I think there is a learning period, learning curve. So if you look at, for example, manufacturing industry, for many years, they always struggled on what technology to adopt, what level of technology they should be adopting, and so on and so forth. Now, of course, they are much better on that right now. Again, data science is the same thing. Again, there are lots of promises. I'm not sure if all those promises can be met. I'm sure the data science itself is going to evolve to the future. I am hoping that there will be more understanding, not just learning. And with that, I think the companies will learn how to adapt and how to optimize it. But I think we are at the infancy of this. So it is good. I mean, good things are happening. Data is very good, but there is a lot to go to learn, and a lot needs to be done.
Yeah. Norman, anything more to add?
I think that Michael's exactly right. If you think about it from the perspective of stock markets and you think about an arbitrage opportunity, those arbitrage opportunities have already been taken before they appear. And we wouldn't have the efficient market hypothesis if that wasn't the case. And Michael's example is sort of a direct analogy to the no arbitrage hypothesis. And I think it's a really good analogy. I think that from the perspective of people that are not sort of deeply cognizant of the complexities of sort of more sophisticated modeling and mathematical tools that are used in the analysis of data nowadays, they might think, hey, I'm going to go with the data. That's the way to go. I've got AI. And when I do that, that's going to give me my answer. And I'm going to be done. Because I know the AI works. They don't realize what I realize, that neural networks are nothing more than a flexible nonlinear model that's just a regression model.
Yeah.
It's nothing complicated. It's been around for decades. We just make it sound complicated.
Yeah.
And so what they don't realize, some of them, is that when they decide to rely completely on data, they're removing themselves from the benefit of their own knowledge. And so in the old days, people used just information and their gut instinct, and they used their internal models.
Yeah.
Now they're saying we don't need to use our internal models anymore. We can use our external models. Eventually, they'll ratchet back towards the middle, and they'll say we need to use our common sense and our economic knowledge and our engineering knowledge, and couple that with data. And once they find the happy median, I think they'll find that the data is providing them much more than they might think. I think they might be asking too much of the data at this point. And of course, as motion suggests and recommends, as time passes, we hopefully will be able to unwrap some of the more complicated models and find out what the real causal relationships and the interactions between the variables or the data that we're using are. Right now, we're at the Wild West stage of, let's throw everything in there. We've got, gigabytes of data, and we'll just process it through some relatively complicated models.
Yep.
And so, but it might have, it'll come back to the middle. But at the end of the day, we have to progress forward with the data. That to me is clear.
Agreed. Now, hearing all of you guys, it's a common theme, right? Like, we underestimate how the factory of making decisions from data. It's a muscle you have to develop, but then it doesn't happen overnight. It's like me watching soccer and then playing with my kids and hurting myself because, I didn't do my stretches, right? And companies don't have a way of managing that risk early on. It's like, hey, if I'm running this for the first time, obviously I'm going to fail. Obviously, there are going to be some setbacks. How do I prepare for that? And put that in my expectation in my project plan. So
if I may can I add just one more? I don't want to get into the technicality of this, but the current technology, also if you look at the resources needed to actually run the current technology right, is enormous. Just very simple example. Many of our models in machine learning are based on supervised learning, and that requires a lot of labeling. And if you really want to build a good model, you need an army of people who can sit down and label. And actually, that's what the companies are facing. So again, we have to go through an evolution. We have to learn. We have to make these models better. And I think we are going in that direction.
Yep. Yeah. John, I know it's 15 minutes left. I want to make sure we have do we have questions from
yeah, we got some good ones. So first of all, not having any data-driven, function in my job, this is great for me to learn from. So thank you to all of you. But I'll start off with the very first question that we received. So based on the enormous amounts of data available, what are some tools that can be used to identify patterns and trends?
Yeah, I think the economist should take this one first, and then we can add.
In the econometrics realm, which are the guys that are interested in developing the statistical tools and in forecasting as well, there's a lot of machine learning being used. In fact, when I was interviewing a couple of years ago in San Diego, I made special note that every single job candidate that we interviewed used the word machine learning. Even if their papers didn't involve machine learning, they had to mention machine learning. So actually, machine learning is really popular, and that's you can think of that as machine learning as there are many different aspects to machine learning, but basically it involves things like dimension reduction. So taking a set of many variables and reducing the number of variables. It involves things like shrinkage, so shrinking sort of coefficients associated with variables so that some variables disappear, they're not useful. There's some of the methods that people use are things like the lasso and the elastic net and the garrote and random forest and neural networks and wavelets. These things have been around for a while, but there have been a lot of advances made on many fronts. In fact, it is the frontier. The use and development of these tools for dimension reduction in the context of data sets with many, many, many variables. And so that's what I would say is one of the key areas. It's all about what they're now calling machine learning, which actually has been around since 1908 in some form. So,
Yep.
but we have made tremendous advances in the statistical frontier in the last 10 or 20 years. And that's where it's at.
And I would add to Norman's advice, right? I think even starting small, when you're saying, hey, I'm looking for patterns in data, what you're asking for is, are there associations between two variables? Meaning, not that one causes the other, but things happen to them at the same time, if you will, right? And just starting small, like saying, are two variables correlated, is a good thing. Now, what happens is, as you increase the number of data, you will find correlations happen a lot. So at this point, you have to then say, so what, right? Like, hey, I see these two variables related or pattern over here, but is it the highest pattern I want to focus on, or is that something else I want to do, right? So you'll have to rationalize that as well. As you increase the number of data, patterns will come out more and more. You have to say, hey, this is the most important pattern that I want to put my energy towards. So.
Yeah, that's absolutely true. And I should stress one thing that I forgot to mention is another of the key areas is the use of large numbers of variables and the extraction from large numbers of variables of small numbers of so-called latent variables that are unobserved that you construct from the data. So you might have a data set with 150 or 1,000 variables, and you construct using statistical methods 2 new variables. And those 2 new variables capture potentially 90% of the correlation that Ronak is discussing between target variables you're interested in and all the other variables. So there's that a sense of dimension reduction too is very important.
Yeah.
Sorry.
I was just going to say that there's some very low-hanging fruit out there. And I guess, because I'm in HR, I see a lot of in the human resources area, but there are companies with very sophisticated data-driven cultures and so forth that get hit with pay discrimination suits. And that's like intro level first course. Here's a very basic test to do HR analytics. And you can do a lot of this stuff with Excel to find, is there pay discrimination going on in your company? And that can be a multi-million-dollar mistake if you screw that up. So much more of it is the culture saying, can we ask these difficult questions? Can we take data and look at it and answer the tough questions? It's not about jumping right to AI and having a super sophisticated algorithm. It's saying what decisions need to be made and how do we make it? And sometimes you could do very simple things with a graph, with a mean. If you want to start getting statistics, a t-test. And some very simple things can make some very big differences.
So in respect to everyone's time here, we have a lot of questions. So that's a testament to you guys. So I'm going to ask the panelists permission to send you the questions in a list and go from there. But we'll try to get to one, possibly 2 more questions. This question actually comes from a former student of Mohsen's, who is now at JP Morgan Chase. And he says, data science is only as good as data quality and data lineage. How does one push that?
Push in what sense? Well, that's a very good point. Data science is as good as the data, garbage in, garbage out. That's we had this for many years. In type of works that I am involved or in engineering, you can say that the data to some extent is verifiable because there are automatic means of collecting data. Just imagine like in manufacturing processes, in transportation, in supply chains, and other physics-based processes, the data really comes, plenty of data comes from sources that are automatic, from sensors, so on and so forth. So that makes data or the data science models a little bit easier to deal with in terms of the integrity of data. But of course, when you go to applications where human is involved and the data comes from human, I'm sure there are lots of issues that you have to deal with. So that problem is there, it's not resolved. And of course, we need to deal with this.
Yeah. And I would like to add to what he's saying. I think I understand the question in a practical sense. What they're asking for is when you're getting data from outside and you're extracting, transforming, loading, it often doesn't. There are mistakes in there, and I think process-wise you should fail early and fail often, right? Getting data ready every month is hard, so you should have true sets everywhere you can, right? Some way of verification at each step before you ingest to the next step. And failing early makes the problem cheaper. Feeling late is harder, and sometimes you lose trust as well. So just being very process oriented about the pipeline, I guess, would be my suggestion on that.
And what we also teach in school to deal with this problem is what we call sensitivity analysis, meaning that no matter how complex or how sophisticated your model is, you really have to run many different types of sensitivity analysis to see how robust of answers you are getting. And I think that can address some of these issues if you do the process, as Ronak said, if you do it right.
Okay, this will be our last question here. So applicability of data to drive action is a clear challenge. What can we do to incrementally and methodically get better at becoming more data-driven more broadly?
I can go first if that's, yeah, I think it starts with asking the right questions. And what I mean by that is, look, you have to be very clear what service you are providing to your group, your organization, etc., right? And pick the service that you're providing, which is of strategic importance. And once you have that, then you start saying, how can I scale this up in a very simple way, right? If I'm providing my service to 20 people, how can I make it happen for 40 people, 80 people, 1,000 people? And that requires change in mindset, right? When you envision that, then that's what I call the envisioning, right? I want to do X. Now, what you're not clear on is how are you going to get there? And you have to let data drive that path. And this is where it's, you have to be open to saying, one, it's okay to make mistakes. Second is, I might not have the answers. That means I have to go and make my data available to people who might have the answers. And a lot of time, what I find is early on, I was not very open with that, right? I was like, no, I need to have all the answers. Third thing I would say is, you have to ask yourself, people always ask themselves, how can I be right? And they go with the first thing that comes across, right? A better thing to do all on top of that is asking, hey, how can I be wrong? And that's when you realize where the shortcomings in your analysis are. And I think if you take this approach of, I would call it a checklist of saying, is this important? Am I thinking of all the options? What's the best option? And then slowly go towards that journey of scaling. So.
Can I go?
Yeah.
I just have something small to add to what you just said, Ronak. The one thing that I've observed over the years is that there are many practitioners and students, they sometimes analyze data and then they say, okay, I have the answer. And I always tell them, no, you don't. And they say, yeah, I did it. I've analyzed the data, have the answer. I said, there is no answer. There's not a right answer. All you can do is tell your boss or your decision maker, or when you're making your own decision, you can say, to the best of my ability, given these constraints, with these statistical confidence intervals, given this set of robustness checks, I can say this. And if you take that mindset at the outset, then you'll be able to convince people in a more reasonable way that what you're trying to show them is something they should use. So ultimately, data analysis is about giving people further information to help them in decision making. It's not about giving them an answer. And what I think Michael said it, and Ronak said it, maybe Moshan too. Everybody said, I agree completely that in the context that we're discussing in this today, setting yourself goals at the outset before doing any analysis is important. And moreover, once you set yourself goals, write down variables that you'd like to have, even if you don't think you can get them. And then once you've done that, find out what data is available and try and match it as best as possible. And then once you've done that, plot, means, modes, correlations, and then move on to the fancier stuff. That's my.
And I would add, I think so much of the obstacle is culture. Does the organization really embrace the culture change? A great example is Moneyball. So many people have read that, seen the movie. That one of the biggest obstacles to data science is the phrase, "That's not the way we do things around here." To be able to embrace a different type of decision making, I think and really embrace it, not just say, "Oh, I read about this is good, we should embrace this," but still do things the way we've done things. It's really embracing the change and allowing that to happen, and let people take those risks.
All right, guys, thank you very much. We're almost to the end of the hour. I don't want to take up more of your time. I just want to thank all of you. This was a great discussion, and based upon the questions and the topic, I think we could have talked for another hour, or if not more. So thank you, and don't be surprised if perhaps we do a follow-up. There will be, for those remaining, there will be a thank you going out to all of you with additional information on ability to contact these professionals here. I will send a list of the questions over to the panelists, and hopefully we can get them as many answers as we possibly can. And just keep your eyes and ears open for the recording of this program that you can go back to on our YouTube channel and review with your colleagues over at JP Morgan Chase. So thank you very much, and have a great rest of the day.